My name is Scott Salesky. I'm an associate professor in the School of Meteorology at the University of Oklahoma. I'm also the associate director for graduate studies. So the job responsibilities as university faculty really break down into three categories: teaching, research, and service. So on the teaching side, I typically teach one course a semester. On the research side, I do some of my own research. So I write computer code, I analyze data, and then make plots, write up the results, submit it to a journal for publication. I also have to write a lot of grant proposals to secure funding to support my research. I also advise graduate students that work with me and do their research. And then other than that, I serve on a number of other committees. I review grant proposals from other scientists. I review journal articles and do a lot of other things like that. Here in Norman, in the School of Meteorology, we're co-located with NSSL, the National Severe Storms Laboratory. And over the years, they've had a number of large field campaigns going out and actually chasing tornadoes with radar trucks and sending up weather balloons, different instrumentation. In meteorology, we really focus on applying mathematics to the atmosphere for predictability. So students are introduced to the equations that govern the motion of the winds and transport in the atmosphere. A lot of it is vector calculus, in fact. Also, a lot of what we do in meteorology has a pretty heavy emphasis on computers in solving some of these equations numerically. If you look at a lot of meteorological data, both from like surface charts based on observations, and then also the output from some of these computer models, you can look at the wind maps that tells you where the winds are coming from and their direction. And this is a really important thing to be able to look at these surface charts and say, okay, for a given day, where are my winds coming from? What sort of conditions do I expect in a given place? If you have a wildfire and you want to say, well, where is the smoke going to spread? You can look at the trajectories in time to predict in the future which areas might be impacted by poor air quality. Sometimes in research, we look at kind of the inverse problem and say, okay, if we have some sort of air quality event in a given location on a given day, you can look at weather data and some of these numerical models and track backwards in time to see where the air came from that's impacting a certain location. So what we look at in meteorology it's similar to, but not exactly the same as slope fields and calculus, but certainly it's giving you a horizontal wind vector, a 2D vector in the XY plane, that you can use to say something about the wind field. And sometimes we look at flow streamlines. So in other words, right, if you would have a steady state wind field and just track the motion of a blob of air, what we call an air parcel, through it, it would follow these streamlines as it's transported along by the wind. These wind maps are really useful, operational forecasters. They'll look at these computer models and look at the predicted wind fields from these computer simulations to look forward into the future and say, okay, a day or 2 days from now, what are the wind fields going to look like? And there's information about what happens close to the surface. They also look at things in the upper air, right? So if you go maybe 8 kilometers or so up, 5 miles in the atmosphere, to where the jet stream is. If you watch the weather at night and the forecaster is talking about a storm system, a week or so from now, he's probably looking at some of these computer models and the wind maps of what the jet stream is going to be doing and the storm systems that it's going to be bringing into this area. When I was about a junior in college, I took a couple of classes from one professor who taught courses in meteorology and in physics, and he had been a polar researcher. So he got his graduate degrees from the University of Wisconsin-Madison, and he actually wintered over in Antarctica in the late 60s. So he just had these wild stories about like being down there on the ice over the winter in the Antarctic, some of the data that he collected, and from his class, it was really eye-opening in terms of like what scientific research was really like. So after that, I kind of got interested in going to grad school and at least getting a master's degree in learning what it's like to actually do scientific research and get some experience in that. So I got a master's degree from Penn State, and I liked what I was doing. I had a lot of fun, so I decided to stay there for a PhD. So really, I came into this career through a little bit different path than a lot of people. So I always liked physics, and this was just a really interesting application of it to the real world. So our graduates here from the School of Meteorology, with a bachelor's degree, students go into a lot of different fields. So some go into broadcasting and they're interested in being on-air meteorologists, and some of them also get like a broadcasting minor from the Gaylord College of Journalism here at OU. So there's certainly jobs like forecasting for the National Weather Service, and there's forecast offices all around the country. It's getting a little bit harder to get into some of those positions now than it used to be. So now, in a lot of cases, you need a master's degree to get hired there by a lot of the forecast offices. There's also a lot of demand for meteorologists in the private sector. So a lot of them are hired in aviation, right? Forecasting for the airlines and making sure aircraft are safe upon approach and landing, and how they route around different weather systems. There's a lot of meteorologists who are employed by supply chain management, right? So your logistics, shipping companies like FedEx or UPS employ meteorologists because they need to know, okay, you know, if there's going to be a winter storm in a given area, how do we route everything around that so we don't lose too much time or money and our shipments get there as intended. There's a lot of jobs in the risk management sector as well. So I had friends from graduate school who went and worked, you know, kind of in the insurance industry, and, you know, kind of forecasting weather risk, right? You hear about hurricanes hitting the Gulf Coast all the time, and insurance companies want to know, you know, what does the probability of that look like in a future climate? Some of these companies are actually looking at putting up their own satellites as well to like collect their own data. So it's interesting, you know, things are going to be a little bit more in the private sector in the future, I think. I mean, we're seeing this, right, with like SpaceX and things like that, and I think this holds true for meteorology as well. So there's definitely a lot you can do with a bachelor's degree in meteorology. On the graduate side are students with who graduate with a master's degree or a doctorate. Some of them go on to doing research, either as university faculty or in some other federal lab. So in our field, you know, the big one is the National Center for Atmospheric Research, NCAR in Boulder, Colorado. So they employ a lot of research meteorologists. There's other laboratories through the DOE, the US Department of Energy, NASA, and other different agencies. So definitely going into research. Life is university faculty. And then there's private sector companies as well that hire a lot of PhDs, you know, Amazon and Google and all sorts of other companies. So we have very, very high job placement for graduates from our department. If you have either a bachelor's degree in meteorology or a graduate degree, there's certainly no shortage of career options that are available to students. For students who are interested in meteorology, I mean, certainly take as much math and physics as you're able to take. So if you're able to take, you know, AP Calculus or physics at the high school level, that's certainly a very beneficial thing. And it'll make things easier for you going into a degree program in meteorology. If you can't do that, or if that's not offered, just take as much math and science as you're able to. It's a more mathematical field than what a lot of people realize, so that's certainly very beneficial. The other thing that sometimes students don't realize is the amount of communication skills they need in our field, both written and oral communication. So if I look at what I do in the course of a typical day, most of it is communication, writing emails, writing papers, writing grant proposals, right, teaching, standing in front of a classroom, talking to a group of students. Some of the folks here in the building, here in the National Weather Center, I mean, there's a very big emphasis on, if you have a severe weather event, right? If you're going to have storms, supercells here in Oklahoma, how do you best communicate that risk and that uncertainty to people in a way they understand, so they act on it and say, okay, I actually need to go to my storm shelter today. I mean, similarly in hurricane season, like in Florida, when they have a hurricane track forecast, people look at that and say, well, this doesn't show this hitting my house. It's fine, we don't have to evacuate, but then it takes a different path, and maybe they didn't understand, or maybe the risk wasn't communicated very well. So certainly on the math and physics side, but some of these communication skills are also very, very important.